Good day. I am Paul Christian Clino Campo Patulot, BS Medical Technology 3 student. Today I am going to show you how to answer the following exercises in Lesson 10, the PCR assay. The first exercise is about the percent volume, and the question is, how does one prepare a 100 ml 70% ethanol solution? The formula that we are going to use is volume percent is equals to volume of solute over volume of solution multiplied by 100. The given in the exercise are percent volume, which is 70%, and volume of solution, which is 100 ml. To solve the volume of solute, we are going to derive a formula, or we're just going to multiply the volume percent in volume of solution. So 70% is equals to volume of solute over 100 ml multiplied by 100. We can just simply divide the 70% and 100, so we can get 0.7 is equals to volume of solute over 100 ml, and we are just going to multiply 0.7 times 100, and the answer for the volume of solute is equals to 70 ml. For the next exercise, we are going to answer exercise 10.2 in molarity. So molarity is also known as molar concentration, and we're going to use the formula CI is equals to NI over V. V stands for volume, and NI is the amount of the constituent in moles, and the volume should be in liters. So the given is NI is equals to 25 mm. So we need to convert it to moles. So we need to divide 25 divided by 1000, and we are going to get 0.025 mole, and then we're going to convert convert 50 ml divided by 1000, and we are going to get 0.05 liters. And now we can use the formula of molarity to get the molarity, or the molar concentration. So CI is equals to our NI, which is 0.025 mole, over our volume, or which is 0.05 liters. CI is equals to, we're just going to divide 0.025 divided by 0.05. So 0.025 divided 0.05 is equals to 0.5 moles per liter. In the exercise, we're going to see the molar mass of the magnesium chloride, which is 95.2 grams per mole. So we need to the amount of constituent is present, and which is 0.025, And the molar mass is also present, the 95.2 grams per mole. So we need to get the mass of substance. So we're going to use the formula, but we're going to derive. So to get the mass of substance, we're going to multiply the Ni and the Mi, which is the molar mass of the magnesium chloride. So mass of substance is equals to our Ni, which is 0.025 mole multiplied by 95.2 grams per mole. We're just going to multiply 95.2 times 0.025, and we're going to get 2.38 grams, and this will be our mass of the substance. For the next exercise, or activity, we're going to get the dilution. The formula that we are going to use is Ci multiplied by Vi is equals to Caf multiplied by Vf. The givens are, our Ci is 0.5 m, the Cf is 100 mm, and our Vf is 100 ml. We need to convert our Cf into moles, so we need to divide 100 to 1000. So we are going to get 0.1 mole. Then we're just going to apply the givens in our formula. So our Ci is 0.5 m, our Vi is missing, or the initial volume, is equals to Cf, which is 0.1 mole multiplied by our volume, which is 100 ml, 0.5 mole over 0.5 mole. Then we're going to multiply 0.1 to 100, which is 10. Then now, we're going to divide 10 to 0.5. And now, we know that our initial volume is 20 ml. Before completing the table, we must first identify the scale down factor. To get the scale down factor, we need to divide the new reaction volume divided by original reaction volume. So our new reaction volume is 15 and our original reaction volume is 25. 15 divided by 25 is equals to 0.6. So our scale down factor is going to be 0.6. Now we can complete the table. First, we need to find the dilution factor by dividing the reagent to final concentration. So 2 divided by 1 is equals to 2. Then 40 divided by 0.5 mm is equals to 80. Then for the primer B is going to be 80 again, and 10 divided by 0.2 is equals to 50. To get the volume, we're going to divide 25 to the dilution factor. So 25 divided by 2 is equals to 12.5. For our primer A and B, we're going to divide 25 divided by 80, and we're going to get 0.3125. For our probe, we're going to divide 25 divided by 50, and we're going to get 0.5. To get the value of the distilled or sterile water, we're just going to add all the volumes here and subtract it to 25. So 25.5 plus 0.31, another 0.31, and 0.5 plus 0.3 for the enzyme, and our template is 2.5. We're going to get 16.42, and we just subtract it to 25. And we're going to get 0.58, and that is going to be the value of our distilled water. Next, we're going to use 0.6. We're going to multiply our scale down to our volume. So 8.58 times 0.6 is equals to 5.15. Next is for the PCR buffer, which is 12.5 times 0.6 is equals to 7.5. Next is our primer A and B. So 0.31 times 0.6 is equals to 0.19. 0.19. Next is our probe, which is 0.5 times 0.6 is equals to 3. 0.3. Our enzyme, which is 0.3 times 0.6 is equals to 0.18. Next is our template, which is 2.5 times 0.6. Next, to get the volume for 9 reaction is we're just going to multiply our scale down values into 9. So 5.15 times 9 is equals to 46.35. Next is 7.5 for our PCR buffer times 9 is equals to 67.5. Next is for our primer A and B. 9 times 0.19 is equals to 1.71. Next is our probe, which is 0.3 times 9 is equals to 2.7. Next is our enzyme, which is 0.18 times 9 is equals to 1.62. Next is our template, which is 1.5 times 9 is equals to 13.5. And that's it. We complete the first table. Next table is the same, but this time we're going to use scale up factor. So to get the scale up factor, we're just using the same formula. We're going to divide the new to the original reaction volume. So 15 divided by 25 is also equals to 0.6. So our scale up factor is 0.6 again. And we're just going to repeat the process that we do in the scale down exercise. So we're just going to divide the reagent to the final concentration. So 280 for our primer A and B, and 50 for our probe. Then we're going to divide the volume to the dilution factor. So we're going to get 12.5 0.31 for our primer A and B, and 0.5 for our probe. Again, we're just going to add this volume and subtract it to 25. 12.5 plus 0.31 plus 0.31 plus 0.5 plus 0.3 plus 2.5 is equals to 16.42 minus 25 is equals to 8.58. Again, we're going to multiply the scale up factor, which is 0.6 in our volume. So we're going to multiply 8.58 times 0.6, and we're going to get 5.15. Next is 12.5 for our PCR buffer times 0.6 is equals to 7.5. Next is for our primer A and B. 0.31 times 0.6 is equals to 0.19. Then for our probe, which is 0.5 times 0.6 is equals to 0.3. Then for our enzyme, which is 0.3 times 0.6 is equals to 0.18. And lastly is the template, which is 2.5 times 0.6 is equals to 1.5. Next is we're going to multiply the scale of values by 9. So we will get the volume for 9 reaction. So 5.15 times 9 is equals to 46.35. Then 7.5 times 9 is equals to 67.5. For our primer A and B, 0.19 times 9 is equals to 1.71. For our probe, which is 0.3 times 9 is equals to 2.7. For our enzyme, which is 0.18 times 9 is equals to 1.62. And for our template, which is 1.5 times 9 is equals to 13.5. And now we also completed the scale up factor table. Thank you guys for listening.